All right, let me give you an example of something that's not piecewise smooth. Okay, so I'm going to start with a equilateral triangle. For some reason, upside down. Doesn't particularly matter. Then I'm going to take on each side here. Let me just call this thing 1 unit. Okay. I'm going to go into the middle of that, the middle third. I'm going to cut that sucker out, and I'm going to replace it with an equilateral triangle's top half. You guys see that? So that was 1 unit from here to here. I took a third out, and I made it a third here and a third there.
I figured after yesterday it was supposed to start, David.
Same deal.
Yeah, knew it.
Okay? Totally unintended. This is a von Koch snowflake.
It's okay, before we had Nazis, now we got you.
Never gonna win this one. All right, then on each one of these, right, you see that there's a bunch of little line segments, right?
Do it again.
They're all a third long. So go into those and take out the middle 9 and do that same trick.
So on and so forth.
Yeah, and then continue this process all the way down to the bottom. Okay?
Which
Is
doesn't
that
exist.
possible?
What's that?
Which doesn't exist.
Which definitely exists. It's just a limit process, right? Take the limit of this thing
Isn't that basic concept?
equals object. Call that thing phi for von Koch snowflake.
I meant if you kept on taking off a third, and off a third, and off a third, and off a third, and off a third.
Yeah, but this is just a
Well, it
limit
reduces
process,
it.
right?
So would that approach some actual shape, or is it kind of like?
Yeah.
Okay.
Yeah, you can actually get a computer to draw you an extremely nice picture of this thing if you take a couple of million iterates of it.
And it's a fractal.
Yeah, it's a fractal, right? If I wanted to think about smoothness, right? If I think about any place on this thing,
It's not gonna be different.
yeah, it's gonna be nasty, right? It's not a function, of course. You guys see it, like, miserably fails the vertical line cut. But of course, I could try to parameterize this thing. It'll never work. I'll never be able to come up with a good parameterization because everywhere is pointy. You guys see that? Like, if I zoom in, you know, here on this little tiny bit, right? And I blow this thing up, what's it gonna look like?
Really pointy.
Yeah, I mean, it's gonna look pointy. It's gonna have a frickin' big triangle sticking out of the middle of it. And then all the middles of those are gonna have triangles.
And the sharp point is not differential.
And then all of these are gonna have triangles. Right, and so on and so forth. So you're not gonna get any better. You guys see that? This thing miserably fails to be piecewise smooth because 1, it's made out of infinitely many pieces.
Would that have a finite area?
This is a bizarre thing. Yeah, it definitely has a finite area. Because in particular, it fits in this square, right?
No, it's just not.
Like, it's never getting longer than 2, right? This distance, you know, if I put this in a square that's 2 across, it's not really getting much bigger, you know, as I go out. We can actually figure out exactly how wide it gets in the end. But suffice it to say, it definitely encloses a finite area. It has infinite length, which is a major pain in the ass. You guys see that? So it's a finite volume or area enclosing curve with infinite length. None of your theorems are going to apply. They're just not going to work. The only vector field I'm going to be able to do anything easy with is like 0, right?
One parallel to the shape.
Yeah, or one perpendicular to the shape or something. Yeah, this isn't going to be easy in any way. Cool? So there are pathological objects out there. That said, you're not going to like stumble onto this thing, right? It's not like you're going to accidentally apply greens to this. You're going to look at that and you're going to say, nah, not doing that. Nah. Yeah, and that's really kind of the point of the mathematician-engineer divide. For a mathematician, these things are important because, of course, I want to check and see if my statements apply to stuff like this. For the engineer, that stuff ain't happening. Except there's a cabbage that looks a bit like this.
I feel like I ate it.